Welcome back to the show. I'm very honored today to have one of my favorite authors and researchers, Dr. Pollack, today. So thank you for coming on, Dr. Pollack.
Oh, it's a great pleasure. Very eager to share the little bit that I know.
Okay, cool. Okay. Well, on today's show, I wanted to actually cover how to source high quality water. And I know there's a lot of brands to pick from. There's like mountain spring water, there's artesian water, there's water treated with reverse osmosis, distilled water, vitamin water, on and on and on. So before we begin that subject, can you kind of quickly just introduce yourself to the audience and your background and what kind of research you're involved in?
Sure, I'm happy to do that. Well, I'm a professor at the University of Washington in Seattle, and we study water. In fact, in my previous life, so to speak, I spent at least 2 decades studying the molecular mechanism of muscle contraction, and came to the opinion that the theory about how muscles contract is bankrupt. It doesn't fit the evidence, and in trying to deduce an alternative theory, it came to mind that practically nobody, has taken into account the role of water in muscle contraction. You see, and water is roughly two thirds of your body, and 2/3 roughly of your muscles, of each one of your muscles, and that two thirds actually expands to if you take the fraction not in terms of the volume, it's 2/3 volume fraction. But if you actually count the number of water molecules that fill up that 2/3, I mean, if you line up every molecule in the cell and start counting, more than 99 out of 100 of those molecules are water molecules. If you do the arithmetic, it works out that way. And to imagine that 99% of your molecules don't do anything, just sit there, is kind of strange. And so that's what got me into water. And we began studying water, and I was influenced by a guy named Gilbert Ling. And Gilbert had just turned 100 years old, and still kicking. And Gilbert was in the first cohort of Chinese scientists. He was picked. There were 3 scientists who were picked throughout all of China to come to the US and study, and he was one of them. Another one is a guy named Wang, who won the Nobel Prize in Physics and is even more famous for the fact that at age 90 approximately, he married a woman of 30. So he's famous in China for 2 distinctions. Okay. Anyway, sorry, did I hear something?
No, I said, okay, impressive.
Okay. Yeah, and so Gilbert spent most of his career exploring the water that exists in your muscles and my muscles. And he said the evidence points to something very different from what we think. We think of a glass of water, and we think that the water inside our bodies is more or less the same as the water in a glass of water. He said, it ain't so. And his arguments were compelling, at least compelling to scientists. His books were virtually unapproachable, even to senior scientists. They're difficult. Gilbert has a habit of writing so that he can understand it, and he's a very clever fellow, but other people have to struggle a bit to get through. But anyway, his message was very clear. And what I started to do is I started by writing a book. It was called Cells, Gels, and the Engine of Life. And it attempted at the outset to make Gilbert Ling's ideas simpler to understand. And I did that. And as I was doing it, I came to the conclusion that, based on the evidence, that it's more than just that the water was different. And I'll get to that in a moment about the kind of water. But that water was actually central to virtually every biological process, that 99 out of 100 molecules didn't just sit there like a bathtub full of water that bathes the more important molecules of life. It actually participated in every function of the body.
Mm-hmm.
And that got us interested in doing experimental studies on water. And so my laboratory pivoted from studying muscles to studying water. And of course, muscles are important, but water is all over the place, and it's central for everything in nature. And so water is a big deal. Anyway, that's the introduction. And what we found is something that has caught the attention of quite a few people, and that is that we learned that water has three states, three phases: solid, liquid, and vapor. And we found the fourth state. And this fourth state is slightly resembling what Gilbert Ling, who I mentioned a moment ago, what he was thinking, but we came to a slightly different conclusion. And the conclusion is, I think, far more interesting. And that is that the water inside our cells, and also outside our cells and throughout nature, that there's a fourth phase of water. And this phase has molecules that are ordered, kind of like soldiers standing at attention, or maybe standing at ease, relatively well ordered, and it had peculiar features and properties, specific properties that make it interesting. The first is that everything is lined up. It's like a crystal, the so-called liquid crystal. So it's different from ordinary water in a glass, because ordinary water in a glass, the molecules in liquid water are organized, they're organized into a disorganized kind of matrix. Each molecule is bouncing around at a gazillion times per second, and they're all randomly oriented. And this is not the case. This is more like a crystal, where the molecules, hydrogen and oxygen, are ordered, essentially almost like a crystal. And another feature is that this kind of water is charged. It's negatively charged, and the region beyond this region of we call it fourth phase water, mm-hmm. or EZ water. For EZ stands for exclusion zone, or easy to remember. And an exclusion zone means that basically excludes essentially everything, all kinds of molecules and particles. But the region beyond it is positively charged. So the fourth phase is negatively charged, and the region beyond is positively charged. So you have a battery, effectively, because you have negative and positive that are separated, just like the battery that that recharges your cell phone. It's the same sort of thing, and which means that if you've got this stuff inside your body, which evidence points to, your body is filled with this kind of water, not with the water in the glass. Mm-hmm. It means that it gives you energy. See, this is an energy supplier. How much energy compared to other sources? Not yet clear, but it gives you energy. So those are some of the essentials of this kind of water that we found. And it's not a laboratory curiosity. It's all over the place. It's inside the cells, outside the body. Wherever you find a surface, a material whose surface is so-called hydrophilic, which means it loves water, which means that if you have a horizontal surface that's hydrophilic and you drop water on it, the water will spread out because the surface loves the water, hydrophilic. On the other hand, the opposite is hydrophobic, like Teflon, where the water beads up. And this kind of water doesn't form when you have a hydrophobic surface, but it forms most frequently next to hydrophilic surfaces. And there are numerous hydrophilic surfaces throughout nature. Most surfaces are at least partially hydrophilic. So this water is all over the place. I forgot one more really important point. Mm-hmm. You know, in order to charge a battery, or to separate charge, which is really what happens when you charge the battery, you need energy. You don't get something for nothing. Even in chemistry and physics, you don't get something for nothing. So there has to be a kind of energy that fuels this buildup of order and separation of charge. And we found that that this comes from light. And it's not mostly not the visible wavelengths of light, you know, from violet to all the way to red, but beyond the red to the infrared wavelengths. Those are the ones that are by far maybe 500 to 1,000 times more powerful than some of the visible wavelengths. So, and this is a kind of light. We can't see it, but it's always around. And if you have an infrared camera, that is a camera that's sensitive to infrared light rather than visible light, even if it's perfectly dark, you turn on the camera and you get a beautiful image. And that's why it's used as used by the military, for example, to see at nighttime. So you can see beautiful images of everything, which means that everything is generating infrared light. And infrared light is the source of energy to build this fourth phase water. So it means that so long as you have infrared light in the environment, and it's really, really difficult to get rid of it, you always have some of this fourth phase water. It could be in rivers and oceans, anywhere there's water and plants and such, and us. So this is a kind of background. I think that's important to understand. And in terms of pathology, see, if you don't have enough of this water in your cells, what it means is that your cells are, what you might say, is dehydrated. And you know, when we're younger, we can often feel this hydration, but as we get longer in the tooth, we are factually dehydrated. We have less water. So someone who's just born, maybe by volume 85 or 90% water, and as we get older, we have less water per unit volume. So we're dehydrated, and if you're gray and bald and such, then you might be in a position where you have 60% of your body instead of 75 or so percent or 80% or even higher when you're younger. So we're chronically dehydrated. And in terms of the water that's inside your body, if you're chronically dehydrated, it means you've got less easy water. And so we know that you can't function when you're dehydrated. I think people's experiences after playing 2 matches of tennis, you know, they're pretty dehydrated. So you sit down on a bench and you drink a whole lot of water, and within a few minutes you feel re-energized and capable of performing what you couldn't perform when you're dehydrated. So what it means is that rehydrating yourself is very important for function, critically important. It's not just water that's just sitting there as the background carrier of proteins and nucleic acids and such. The water participates in everything that goes on in your cells, and you need to keep that fourth phase or easy water up to a certain level to perform properly. So that, of course, has therapeutic implications, because what you want to do through any of various means, which if you ask me, I can talk about, to get yourself beyond just drinking, of course, drinking water.
Well, really quick, Dr. Pollack, before you continue with that statement, like as you mentioned, it's kind of like one of the most important nutrients like a person can have to optimize their health. And a lot of people obviously don't view water even as a nutrient. They kind of don't view it kind of like as a food group that could have health promoting benefits. And I know like a lot of books on health and wellness that promote, you know, water, they typically compare kind of like soft water with hard water. And they typically always encourage people to drink like more hard water. And they also use like the base marks of like measuring total dissolved solids, hardness, and pH to determine if that water is ideal for drinking based on those 3 variables. What's your take on that?
Well, I guess those are useful. I'm not sure of the evidence, clinical evidence or other evidence that supports that notion. It's based on some logic, I suppose. But for me, more important than that is how well does it hydrate your cells? And it's possible that the hard water with minerals in it can hydrate your cells better than softer water. I'm not sure. Some of the spring water has a lot of mineral content, and various people through anecdotal evidence, not clinical trials, but anecdotal evidence, imply that this water is actually good for health. So that might be, but from the discourse that I went on at length.
Yep, no problem.
I provided. For me, the best water is water that contains a sizable fraction of EZ water in it. And because, you can drink water, but most of that water often gets peed out. Some of it gets absorbed and converted into EZ water inside your cells, and that's what you need. But it's not the major fraction of that water. On the other hand, if you were to either drink EZ water itself, some people would call it structured water, then you're directly infusing into the body the stuff that your cells need. So, by logic, this is I think a better way to go. It's not so simple to know which waters contain fourth phase or EZ water. There are many of them on the market. You generally won't find them at supermarkets. You'll find products that belong to the companies, the beverage makers who make sugary drinks and such. Mm-hmm. They realize that there's a market for good water, and they're marketing that. But I'm talking about ones that you can find on the internet, and many of them boast that they have structured water. There must be dozens at least, if not hundreds, from all over the world that claim that. Some of them say EZ water or fourth phase water, and one needs to ask, though, what is the evidence that they actually contain such? And I'm not sure, and I'm not speaking for or against any of those waters, but I think one needs to be a little cautious. There have been, for example, there have been reports about a kind of alkaline of water, and this started in Japan long ago. I can't remember, I think 40 or 50 years ago. It's called Kangen water. It's a type of water that has high pH. So they take water from a source. I'm not sure which source. It could be your sink or your tap water or someone else's water, and put it through a machine. And this machine, what it does is it passes the input water through two electrodes. One is negative, one is positive. Mm-hmm. And the one that passes through the negative electrode, it's a platinum electrode, it comes out with high pH. And high pH is thought, and there is evidence for this, to be good for your health. And so these machines began to spring up in Japan, and now they're made, some of them are made in Japan, and some of them are made in Korea. And it's gotten a lot of good press, though lately some mixed press. And because of the mixed press, the Japanese government did clinical studies. And here I'm pointing to an area that's, I think, really important, because you can praise a kind of water up and down, but if you don't have studies to prove it, then it's just a matter of speculation and conjecture. Mm-hmm. So in this case, they actually went through the clinical test, and according to my source from Japan, who studied this kind of water, the tests were so incredibly positive that right now, if you have a medical problem that involves your gastrointestinal system, from your mouth to your rear end, anywhere, the Japanese government will pay for you to drink this kind of water, because the clinical tests have proven so positive that they know that it will cost the government less to pay for you to drink that water than it will cost them if you didn't drink the water and you remained ill. That's how positive the results were. So I'm
not sure U.S. pharmaceutical companies would like that research to go mainstream.
Yeah, well, you put your finger on it, and really on an important issue, and this applies to a lot of so-called alternative therapies that have arisen all over the world. And and the pharmaceutical companies, obviously, it's not in their best interest to have these alternative ways of healing to be mainstream, because it will encroach on their future and their well-being. And this is a limitation that so many alternative or complementary or integrative physicians complain about on a daily basis, because the pharmaceutical companies are replete with plenty of cash in their accounts, and therefore they have a lot of power. And so for any alternative, whether it be a supplement of some sort or food of some sort, which is not, of course, patentable, it's difficult for them to gain traction. And if they want to do clinical trials, it's so costly that effectively the only groups of people who can do that are the pharmaceutical companies, because they can pay the price. So it means that the alternatives, whether it be water or other kinds of medicines or supplements, they can't get the traction that I think they deserve to compete with what the pharmaceutical companies produce, to see which ones are more effective. So that is a problem.
Well, what's your take on, in terms of like sourcing easy water? Is that able to be attained with, like if you're drinking distilled water or water treated with reverse osmosis, for instance?
Well, it's theoretically possible, but it's less likely. And we're actually working on that, because you might get the impression that I think that water that contains easy water is going to be good for health, and that's based on various pieces of evidence. But it's not so easy to produce, because typically the way to produce it is to put the water, have the water interface with one of these hydrophilic surfaces, and then from the infrared energy that's coming in to power the buildup, the easy water builds up, and if you're able to collect it, then you've got a lot of easy water. And we're working on that. We're working on ways to collect it, and we actually have a little startup that we produce, because we want to make this available for the world, because we're convinced that this is the kind of water that will turn health around. That if people are drinking this water, it could be powerfully supportive of health. And we have evidence for this, not clinical evidence, but we have evidence. So yeah, it's not so easy. It's not so easy to make. It's a technological challenge. You can make small bits of it. That's really easy. Anybody could do it. But to scale it up to proportions that would be really effective for society, that's a big deal. Yeah.
So does more stages of filtration, like if you filter the water heavily, does that kind of decrease the chance of having easy water accessible to the drinker?
You think so, but actually it's not true. So we found, oddly, if you take a filter, a standard cellulose-based filter that's used in every chemistry lab and at home to make coffee sometimes, if you put water through it, it turns out that some of the water that comes through is EZ water, is fourth phase water. We were a little surprised. An Italian researcher named Vittorio Elia demonstrated that earlier, and we repeated that and have done many more experiments, and it seems to be true that that's the case, that it produces a decent amount of EZ water. That is one way you might actually produce it, but chemists are unaware of this, and many chemists are unaware even of the existence of EZ or fourth phase water. It tends to be traditional to stick, even among scientists who, one would think by definition they're going to be open-minded, but they're like everybody else. We feel comfortable sticking to what we think we know. It's a comforting feeling, it's a secure feeling, and when someone comes around with a proposal or idea or even really solid evidence for a completely different point of view that challenges the existing point of view, people are not so open. Scientists, like others, are not so open to that. It's sort of like the political scene. There are two factions in our country that look like they're equally divided. And it seems that there's almost no way to change any one of those two groups to think oppositely, no matter what the arguments. So, yeah, I think people understand that very well. And this syndrome afflicts scientists also who feel secure in their fund of knowledge, and it feels a little insecure for many, not all, by any means, of course, to be challenged with a completely different point of view. There have been a lot of experience. This is another one of you might say my interest, deep interest, and I've written on this subject, and we also have an institute called the Institute for Venture Science to challenge this idea, to actually provide means by which scientists who challenge the status quo with reasonable ideas, highly vetted, to get some funding to get them started and give them a chance to present their point of view in a way that other people have to listen to. So this is a really critical point of view. I'm sorry, I went off on a tangent.
Nope, totally good. All the information's like very helpful.
Okay, well that's great.
Well, what's your take on, I don't know if you know too much about like water breweries, but basically these are kind of businesses that for the most part like run water through a reverse osmosis machine, but then they kind of remineralize it with like different types of methods. I mean, it varies from company to company, but they kind of put it through seaweed or some other stuff, and it kind of brings up the nutrient density of the water, for example. Like, how do you know how that affects the kind of like fourth phase of the easy water that you've been describing?
Well, I'm sorry, I really don't know. But of course, reverse osmosis water contains no minerals at all, essentially no minerals. And I think people have generally come to the conclusion that that's not necessarily a good water for you, because the water inside your body, if it's not fourth phase water, I'm not suggesting that all of it is fourth phase water, most of it. The overwhelming majority, there is some other water, and all that water contains salt. So it makes sense that or that means minerals, it makes sense that if you drink water, the water should perhaps have at least some of those minerals. I'm not familiar with any scientific tests of that water, or I should say clinical tests, because that's what we're looking for. But there may be some that are beyond my awareness. Our work is in defense is mostly scientific work to find out about the chemistry and physics of water. We don't do evaluations or testing of different waters, and that's why my response is maybe a bit sketchy about some of the waters that exist right now that you can actually purchase. I'm simply not sure of the answer.
Which is totally okay. I was just wondering your perspective on basically, I guess for the general audience, like easy ways to source water that has like an abundance of easy water accessible for a person that drinks it.
Well, there's a way actually to measure it, and it's not too complicated. It involves a scientific instrument, but this instrument is available in every chemistry laboratory at every university or any laboratory that deals with chemistry. It's called a UV visible spectrometer, and you can use that machine. In 15 minutes, you can test to see whether the sample water does or doesn't contain fourth phase water. And it's very simple. You put it into a container. It's called a cuvette. Put the water in the cuvette, and put the cuvette in the machine, press a few buttons, and the person in the laboratory that houses the machine will know how to do that. And see, what it does is it inputs different wavelengths of light over a range of wavelengths, and it tells you which wavelengths are absorbed by the sample. And so we found experimentally that if a sample absorbs light at a wavelength of 270 nanometers, then it contains easy water or fourth phase water. And the more it absorbs, the higher the fraction of easy water in your water sample. So it's not a complicated way. It just requires access to a machine like that. And if someone is serious about finding out whether their water contains structured or ordered or fourth phase or easy, or all the same thing, that's the way to go. At least that's what we found is the way to go. And you know,
is that pretty accessible? Is that like really expensive? I never heard of that UV visible spectrum.
well, yeah, if you're not in the chemistry field, you wouldn't know about it, but it can be pretty pricey. You can also order used ones online for much less. I don't know how much less, but if you have access to any kind of chemistry laboratory, you know, you contact the university and ask them, and typically sometimes you can walk into the lab and you can ask them to do you a favor, and if they're not too busy, they may do it, or they may charge you some nominal fee for the technician who operates the machine to do it. It's probably better off that way. If you're serious about this, it could be worth it. And probably in any major city, there are dozens, if not hundreds, of such machines. So it's not so difficult to gain access. Or if you're serious and want to do many of those tests, you can buy one of the machines, and a used one, if it works, is probably a better deal than a new one. New ones have a lot of automatic features which are not necessary for this kind of experiment. So that would be a way to go. And I'm convinced from the evidence that the water that contains a lot of EZ, a lot of fourth phase water, is going to be better for health than waters that don't contain that.
Would you say kind of like, I always wonder just from personal observation, like, does water that's, for instance, bottled and sit at the grocery store, for example, for a few weeks before you drink it, kind of contain less easy water than water that, for instance, you would just sip right out of like a moving mountain spring?
It's hard to say. I mean, if they contain any EZ at all, we're just now doing experiments to see how long EZ water persists, and we don't know the answer. I do know that it does persist for at least some time, because someone 7 or 8 years ago claimed that the water that he produces can reverse irreversible kidney pathology, and I was intrigued by this. When he called me to tell me, I was a little bit doubtful, but he sent me hospital records, and I invited him then to speak at. I organize each year an international conference on the physics, chemistry, and biology of water. This year, for anyone who's interested, it's a science meeting, but I think most of the science is understandable. It's in October right near Frankfurt at a town called Bad Soden, a 20-minute drive from the airport. And people, excuse me, I lost track of why I was talking about this conference, but people come and present and discuss different kinds of waters, and some do speak about water and health. So I think it's a generally interesting conference. And if anybody's interested, the URL is waterconf.org. So conf for conference. So it's a simple URL, and it's a meeting where people get together and it's friendly. It doesn't feel like most scientific meetings. A lot of exciting things are discussed at that. And one of the And again, people are interested in what kinds of water are good for health. So that is discussed there. One of the things that I don't know if you want to get into, but because this is kind of seemingly slightly off topic, but I think it's getting to be very important, because there are a lot of presentations at our conference that deal with this. And if you got other questions that you prefer for me to answer, I can just shut up about this. But it has to do with information stored in water, or memory of water. I don't know.
I studied that a little bit. Yeah, that's a very interesting subject.
Yeah, I mean, it seems bizarre. How possibly can water store information? But experimental evidence dating back 30 years or so and presented increasingly by scientists seem to show that water does have the capability of storing information. And if you think about the implications of that, if your body is filled with EZ water, then it means the water in your body has the capability of absorbing information and giving out information. And nobody understands at all how this is accomplished, because it seems to work even over long distances. There are some experiments that demonstrate this. So it doesn't do what standard electromagnetic energies do, and that is to dissipate over distance. It's actually 1 over the square of the distance. So if you're 1,000 miles away, it's very difficult to get any kind of electromagnetic energy. But this seems to be almost independent of how far you are. You put your intention on a certain water, focus your intention, and the water changes in some way, and that change is retained. So the classic experiment, it's becoming classic, it was done by a guy named Luc Montagnier, who happened to win a Nobel Prize earlier for discovering HIV. And he was so intrigued with the idea of information in water that he changed fields, at least temporarily, to look into this. And he demonstrated that you can take DNA, some sort of DNA, obviously with a specific, a short strand with a specific sequence along the DNA. That's the critical feature, of the DNA. And he put it next to water, and the two containers were sealed so they couldn't communicate with one another. And he found that the information from the DNA got stored in the water, the flask of water that was sitting next to the DNA, but not physically in contact in any way, because when he used that water to make new DNA with a technique called PCR, to amplify DNA, the sequence of the new DNA was the same as the sequence of the DNA that sat next to the water. This is incredible. And it seems that this has been successfully repeated in several other laboratories. So this is nothing short of amazing, if water really has this capability. And if you think about water, if you think about ordinary water, there's no way this can happen, because the molecules are bouncing around, they're randomly oriented, and there's no way for something like that to store information. But the situation differs with fourth phase water, because that's a crystal. And if you think about the thumb drive that you use in your laptop, basically it's a crystal too. It's a crystal of silicon. And there are many features that fourth phase water and silicon share. There are molecules that are organized in 3 dimensions. It's like 3-dimensional arrays. See, so there is the capability of fourth phase water to store information. And since your body is full of fourth phase water, it means that subtle energies that come your way, what you might call nuances of sensation or feeling or something, or insights and such, these are the information from outside has the capability of being stored in the water. I'm not suggesting this just out of a whimsical idea. I'm suggesting that many groups are now reporting results like this. And if there are results, it seems that as scientists, it's obligatory to find out what's going on. And so there are multiple groups who are trying to figure out how this works. Nobody understands it yet, but the evidence says that it's there. So when you drink water or think about water, you got to come to realize that there may be other dimensions of water that are really important, that very few people, except those who are intimately involved with trying to understand water, are pursuing. This could be extremely important, a kind of subtle energy that exists that very few people even think about. For me, this is very exciting.
No, that is very cool.
Hey everyone, thanks for checking out this podcast. If sourcing high quality food is something you're interested in, but definitely find the subject matter confusing, check out my book on Amazon titled Anti-Factory Farm Shopping Guide. It's a very easy and non-technical read that's beautifully illustrated and comes with a comprehensive video series and other extended learning material. The book, in a very simplified way, breaks down the difference between caged, cage-free, free-range, and pasture-raised meats. It'll cover how to avoid GMOs, source high-quality water, fish, supplements, and many other related topics. Thanks again for checking out the podcast, and when you have a second, please check out Anti-Factory Farm Shopping Guide by Eugene Trufkin on Amazon.
I think there was a book on it. It was written by like a Japanese guy, right? A while back.
Well, I think you're thinking about Masaru Emoto.
I think so. It's been a long time since I've read that book. I totally forgot the name of it.
There wasn't much to read in the book, although the book sold 6 or 7 million copies. And in fact, following this interview, a couple of the Emoto people who are in the U.S. are visiting me, and we're going out for a meal together. So I've come to know the people in that organization very well, and they asked me to write a foreword to their new book that just came out a couple of months ago, which I did, and I was invited to give a talk in Japan. And yeah, so for those of your listeners who don't know about Emoto, he was a spiritualist, and what he did was he focused his intention on water, and in many different ways, either by thinking something or by writing something and putting it on the container of water, or by playing music that would appeal to most people versus music that would appeal to only a very small segment. He was able to show that when he froze the water, the crystals that formed were beautiful if positive intention were put to the water, like thinking to the water, "I love you," and ugly crystals when the intention was, "I hate you." See, so and again, you know, there are scientists. Most scientists think that this is the biggest nonsense, and one of the difficulties admitted by Emoto was that they cherry-picked their data. He chose, so he might freeze 50 samples of water and choose the 2 or 3 best ones that illustrated what he wanted to show. And as a result of that, scientists, of course, understandably, are highly skeptical, because that's not the way to do science. They've begun actually doing more objective experiments, and where our stuff fits in and why we have a good, close relationship is that the discovery of fourth phase water sets a basis on, because it can store information, subtle energy kind of information. It forms a basis on which you can speculate that what Emoto found is really genuine. We don't offer proof that it's genuine. That's to be decided when the more objective experiments come. But we understand there is a basis by which this could certainly be correct. So some of a little anecdote. I was recently in Abu Dhabi, and I was invited to give one of these special lectures that Bill Gates gave earlier. It's called the Modulus Lecture, Modulus meaning assembly or parliament or something, of the Crown Prince. And the Crown Prince is an esteemed character who is widely cherished by all the people in the United Arab Emirates, where Abu Dhabi sits. So I was really overwhelmed to get this special invitation. I was a bit nervous, and it was in front of 700 people, including VIPs, and in the first row, I was told, is reserved for the VVIPs, namely, the sheikhs from different emirates and from Saudi Arabia and whatever, and all dressed, the men on one side, the women on the other side, in whites and blacks, and it was quite an event. And I I think it went pretty well. But in order to do it properly, I thought it would be interesting to put some of the Emoto slides in the presentation, even though the presentation was restricted to about 35 minutes. So I asked one of my friends who deals with the Emoto group if there's anything in Arabic, and he says, sure. So it turns out that there are 99 names for Allah, and one of them is the Just. And so what they did in Japan is they took a piece of paper, and in Arabic they wrote the Just, and they exposed, I think they took the paper and either glued it on the glass container or placed it immediately beside, so that the letters were exposed to the water for 24 hours. And the crystals that came out of that water are among the most beautiful that I've ever seen. So perfectly symmetrical and lovely. So I showed that, and I think it went over in a big positive way. So yes, the Japanese Emoto and his crew, and they're carrying on after his demise 4 years ago. And the new book is out. It's called Messages from Water - The Final. And you'll actually find a little bit about easy water and some things that I wrote in the book. And mostly it's images that they've collected from over the past 20 years. Beautiful images, and some ugly ones, beautiful images that were obtained when the water was exposed to the, quote, proper kinds of information. Very interesting to me. And there's the famous rice experiment that many, many people have repeated, and they claim success. So you take a piece of paper, 3 pieces of paper, and on one of them write, I love you. Another one, I hate you. And the other one, I think you leave it blank. And you take 3 containers of rice, all prepared at the same time, in containers, in glass containers, and you stick these labels on the outside so the words face the water. And it turns out, many people have told me this anecdotally, that the one where the words are that say, I love you, the rice essentially never rots. It's there. And the one that says, I hate you, turns dark black after some time of exposure. And the worst one actually is the one that's left unattended with nothing on it. And the odd thing is, it doesn't matter what language this appears in. So it's very difficult to understand how that works in the mentality that most of us have. But again, I think it would be interesting if the tests could be done by some scientific group objectively and report the results and see if they turn out the way so many amateurs have determined. And if it's right, then it's necessary in science to figure out what's going on. So this is way off the beaten path, and but it's intriguing, for those who are intrigued by phenomena that are not understandable. So anyway.
Well, circling back a little bit, I don't know if you're familiar with biodynamic farming and kind of Rudolf Steiner.
I am.
Oh, you are?
Well, I mean, I guess not as an expert, but as a lay person, yeah.
Well, that's pretty cool. I ask because most people don't even know when I mention his name or even that kind of farming practice. So, but I remember one time he preaches kind of like stirring a pot of water for a while. I forgot the exact time interval.
I think 30 minutes.
How many minutes?
I thought 30 minutes, but I might be
30
wrong.
minutes. Okay. I forgot exactly. It's been a while since I read a few of his books, but is that like a method of increasing the amount of easy water that's accessible?
Might well be. So when you stir, you create a vortex if you stir vigorously. And my recollection is 30 minutes in one direction and 30 minutes in the other direction, but I might have that wrong. And also, if I remember correctly, isn't it true that you put a small amount of organic matter in the water before just a minuscule amount? And so I think that both of those approaches will build easy water. So when you stir it, you create the vortex. And others have determined that if you have a vortex, you have a different kind of water, so-called living water, and that started with the great naturalist Victor Schauberger, and has been taken up by many other people. And in particular, if you've got organic matter in the water, you don't need much of it, just a small amount, then the easy water builds around that organic matter. So by putting the organic matter in, and by stirring the water, you get a vortex, you get, I think both of those two, although we haven't tested it, both of those two should build easy water. And easy water is not only good for people, it's equally good for plants. And that may also, sorry to digress, that may also explain why when you water plants, when plants get watered through rainfall rather than through irrigation, the farmers claim that the water is much, much better for growth. Because when it rains, we found, and this appears in my book called Fourth Phase of Water, you have droplet of water. The droplet consists of a shell that makes it spherical, a shell of easy water, and inside the droplet, inside the shell, is water with a lot of protons, and protons, positive charge, they repel each other. They create a pressure against that easy membrane, and that's why the droplet is close to spherical because of that. And because the water contains EZ, you see that should be promote health of the plants. So yeah, biodynamic farming. I read about a year ago that there was a company or some grape growers in California who were using biodynamic techniques, not despoiling the earth with all kinds of chemical fertilizers, and claiming that not only do they get wonderful grapes, but it's actually economically feasible to do this. The reason the chemicals are used is mostly to shut out, get rid of the weeds. And so the question you need to ask is, well, if it kills the weeds, what's it going to do to us? And the companies claim that it has no effect, but so many people, so many scientists have shown that the main ingredient in Roundup, the stuff that's produced, is glyphosate. And glyphosate is not good for health. And we found in experimental studies that glyphosate diminishes the amount of easy water. So if easy water is critical for health, and you take something in your body after you eat the corn that's been sprayed with this stuff, it's understandable. It's understandable why people are sick. Many more people are sick now than they were years ago. It's getting to be a serious problem confronting humanity. So yeah, biodynamic, it's rather natural, except some of the things are a little bit weird, but like I think you take cow dung to start with and put it in the horn of a bull and bury it. And I think that's the stuff after it disintegrates that is used to put in the water that you then stir. I may have those facts slightly wrong, but I think
there's various levels of integrity of biodynamic farming.
Is that right? Okay.
But actually to touch on your kind of comment of rainwater being more effective for crops versus kind of filtered city water, for example, I think like Dr. Elaine Ingram did a really good podcast on that. She's like a soil biologist. She's basically like the queen of the soil of food web. And one of the biggest reasons for that was actually because there's a lot of chloramine in the water. That's treated, and that kills like the soil food web in the soil, and then obviously that's where the plants get all the nutrients from, is that soil food web, because a lot of people don't know, but like chlorine or chloramine, that's a pesticide.
And we drink it all the time.
Yeah, exactly. I mean, you swim in it, it's in your shower as well, it's in your tap water for sure, unless you have like a chlorine or chloramine filter. So yeah, that was interesting that you mentioned about the rainwater, because I thought for sure like easy water wouldn't be present in there, or maybe present at a very low level, because it's kind of like, isn't rainwater pretty close to distilled water in terms of its composition?
Well, in the sense, that it doesn't have many impurities in it. It's essentially water, but easy water is water too. It's water that's changed into a different phase, and Um, well, you have to ask yourself, what makes rainwater, what makes clouds? And without digressing too much, here's a question that might interest you and your listeners. If you take water and pour it from a glass, it goes down, right? It doesn't go up. And so a question is, what keeps the cloud, which consists essentially of water droplets that are somehow held together some distance from one another, what keeps those water droplets floating in the sky? Maybe it's a question that you and most people never think of it. They look up, they see the clouds floating, and they think, well, gee, nothing strange about that because you see it from the time you were born. But if you think about it, it's really it's not trivial to reconcile the idea that when you take some water, little droplets maybe, pouring from a glass, it always goes down, yet it stays up. Why does it stay up? Why doesn't it keep descending the same way as the droplet from your glass descends? So this is another topic to get into, but I'm bringing it up to illustrate that there's a lot of stuff about water that people, or most people, don't understand.
Mm-hmm.
So it's not just what water is best for you to drink, because that still is not completely clear. Although my own view is that based on evidence that it's the EZ water that is best to drink. But there are a lot of things about water that we simply don't know. Most people think that water, it's the simplest substance on the face of the earth, practically, and it's all over, everywhere. And scientists have been studying water for a couple of centuries, or at least one century. And therefore, everything there is to know about water must already be known. So how is it possible that we can't answer these simple questions? So it's something to think about. And water used to be a topic of scientific research, but there were a couple of debacles that took place among very famous scientists who thought they had found something, and it turned out, at least according to mainstream points of view, that they screwed up and they were terribly wrong. And because of that, scientists are reluctant to immerse their toes in water, so to speak. I'd rather do something else, better study genome science. If you study water, it's dangerous because of in the last, 50 years, two really distinguished high-level scientists essentially lost their careers or came close to losing their careers because of something about water that they found, which others subsequently argued were not true. They were interesting things, some of which I've talked about now, but they were ridiculed, and their career was ruined. And so water science is not one of the mainstream or popular topics in science because of fear of scientists of getting involved. It's too risky. You lose your career, you lose your funding, and if you lose your funding, you can't do anything. And if you can't do anything, you can't put food on the table of the people who work in your laboratory, and even yourself sometimes, supported by grants instead of more harder funding. So there's something about the structure of science that has been interfering with the willingness of scientists to move into areas that are seemingly more radical. They become less radical when people begin to study them and accept them. So every scientific finding, from the time of Galileo onward, every scientific finding, even Einstein's findings, were ridiculed when he first came out with the idea of relativity and such. And it was not until he got a Nobel Prize for something else that he did, the photoelectric effect, which many people think were hugely influenced by his wife at the time. Then he was accepted. The other ideas were widely accepted, but ridicule comes first. And even today, it's not much different from the way it was at the time of Galileo. Church didn't like the idea that the sun might be the center of the solar system. You know, they like the idea of an Earth-centric solar system. But then, you know, when mathematics developed and people could compute the orbits of the sun and all the planets around the Earth, they became so complicated that it wasn't long before people realized that this is impossible. So, you know, and then the church, the main opposition, refused to look in Galileo's telescope so that he could prove his point. It's what I mentioned earlier about that scientists feel comfortable in their way of thinking in a way that is a bit like religion, where at least some religions there's a dogma and we're expected to accept that dogma coming from high authority. And science should be the opposite. We should be challenging authority, even when the authority comes sometimes from towering scientists who everybody thinks are, you know, the greatest scientists who ever lived or something like this. That becomes more like religion. And so,
well, kind of circling back in terms of, you mentioned really quick, kind of the still large amount of mystery that revolves around water and humans' ability to basically understand it. I always wondered, like, when you filter the water, like even with small, like minor filter, for example, or even something as extreme as like a reverse osmosis machine, I'm always wondering, like, what things you're kind of killing in the water that scientists haven't yet discovered. You know what I mean?
Well, one doesn't know because, you know, I guess it's that famous saying that one doesn't know what one doesn't know.
Yeah.
One doesn't know how much one doesn't know because, yeah, and you know that's one of the reasons why sometimes experiments on water is difficult to repeat them. So typically in science, one expects that if there's a finding that is really oddball, in order to believe it, you expect some other laboratory to repeat it and get the same result. And sometimes that happens. And with water, it's more difficult. And the reason it's more difficult, I think, is that there's so many things that are unknown about water. And if you don't know what variables might influence the water, then there's no way to control for it. And therefore, if the same experiment is done in two different laboratories, where these unknown events remain unknown and therefore uncontrolled, then you can easily get vastly different results. So I think we're at the beginning of understanding of water. One of my books, the one I mentioned earlier, Cells, Gels, and the Engines of Life, it's now almost 20 years old, but it points to it points to water being the central player in so many processes of the cells. And you know, if you don't know all the processes, then it's hard to know exactly what to predict. So water really needs to be studied intensively by seriously open-minded people, because there's a lot more about this substance that needs to be understood. I think that we've kind of cracked open a bit of a door to understanding with uncovering the fourth phase of water, which, by the way, I should say, 100 years ago, a famous scientist, colloid chemist, came to the same conclusion. There must be a fourth phase because there are too many things that three phases can't explain. And there are all kinds of lists on the web of so many things that are unexplainable with our current understanding of water. So a lot more needs to be known. You need to induce scientists to begin studying water in their own creative way, because there's so much that we need to learn about it. And only then will we then understand what not only I, but increasing number of others think is the most important molecule on the planet.
Well, what are there, there's like a tremendous amount of trace amounts of chemicals in like the water supply these days. What kind of steps do you take to kind of reduce your exposure to that, but still gain the health benefits of drinking like nutrient-rich water that hasn't been too excessively filtered or stored for too long?
Well, there are two answers. One is what is our lab doing, and the other is what do I do? I'm not sure which one you asked, but I'll answer both.
Either or. Your
Either
opinion.
or. So in the laboratory, or I should say in our startup company, we're working technologically to produce a filter that actually, in the laboratory, it has been demonstrated to filter out essentially not everything, almost everything, all of the junk that's in the water. And we can do it in the laboratory. We're now scaling it up so that it will be useful for the general, for everybody in the world. It's a very simple one, and it doesn't involve a physical filter. The filtration comes when the fourth phase is created. The fourth phase actually excludes or rejects all kinds of contaminants. So it's a matter of collecting that fourth phase. And we have a company, and we're limited. Basically, we're limited by investment because it's a small company. We could use more investment, and the larger the investment, the larger the number of personnel that we can devote to scaling this up for eventual use throughout the world. And so that's what we're working on, and we think this is really, really important. So that's one. And also, by the way, it looks as though we can separate salt from water. This is not definite yet, but the preliminary experiments look encouraging. So eventually, with development, we're hopeful that we can take ocean water and produce drinking water without any physical filter and without any energy except the energy from the sun. I mean, infrared energy. So at home, well, you know, people like to offer a different kind of water for me personally to drink at home. And the rationale behind it is there are a couple of different rationales. One is, well, this guy will appreciate it. And the other rationale is maybe this guy will talk about it and could do some good for our business and whatever. So at first I rejected all such attempts. And my late wife would say, gee, instead of drinking none of them, why don't we drink all of them? and her wisdom, which was great, we started doing that. So I got all kinds of waters from different places that I personally drink, So I'm not sure if I should mention all of those because that would be an advertisement for those people. But these are people waters that come from people whose opinions I respect, and I think between the waters that I have here in my home and the ones I have sitting on my desk at work, I probably have maybe 7 or 8 different kinds of waters that I thought were at least worth drinking. So I kind of rotate among them. Does that help?
Clear enough. So you got a large variety of water. I just thought maybe someone like you maybe would have some like super elaborate filter and remineralization process that's like super crazy elaborate. But
well, Eugene, you know, the truth is that I think that nobody really knows for sure. And I think the way that someone would know for sure which one is to do clinical tests comparing the different kinds of waters, but clinical tests to see which ones fare best. So, for example, someone has kidney disease and they're volunteer to drink these waters instead of drinking tap water, and they do that for 3 months or something. And you compare water A, B, C, D, E, and so on with tap water, and you see which patients fare best. That's not simple. It requires a lot of money. It requires probably, we had applied to the National Institutes of Health to do that kind of study, and I think we're well equipped because we understand more than some, at least, about water and what's important. But you know, the NIH, I hate to use this generic kind of phrase, but they never heard of water. Most of the scientists who do the reviewing for any of these organizations, water is not something they deal with. You know, if you go to NIH and you're studying genetics, oh yeah, sure, we understand you. Maybe we'll give you some money if you survive the competition. But water, you know, that's just something you bathe in or something you drink. It's H2O. It's nothing beyond that, and therefore no money. They won't even look at, or they historically, they didn't even look at the application because it was too far out. There is a system there that works that way, where there's an initial screening by some reviewers, and unless your application passes the initial screening of those reviewers, it never gets discussed. And so it's necessary in order to do a study like that. I think $5 million or something would be the minimum that's needed to do it effectively, because you have a lot of patients to deal with, a lot of workers, research workers to deal with it. It's not simple to do, and a lot of permissions required, et cetera, et cetera. So you need someone who's devoted, who's willing to do it, and then I could imagine that this would be one of the most valuable pieces of research that the National Institutes of Health is undertaking, because everybody wants to know, what kind of water should I drink? And the truth is, nobody knows.
Mm. Gotcha. Well, do you have any
knowledge, but nobody really knows. So there is another resource that I might mention while I'm here. It's called the Hydration Foundation, and I don't know their website address, but if you search under that, you find interesting information about water and how to keep yourself hydrated. And there's a book that goes along with it, written by a couple of friends of mine, including Gina Bria, and it's called Quench. It's been very popular. It deals with hydration and how to keep yourself hydrated. So I recommend that one.
Gotcha. And I guess just like a random last question before we close it up, is it true that there's like a huge, this is a little off topic, but there's like a huge actual like water shortage in the world, like drinkable water?
Well, a lot of big companies are buying up some of the water resources that we have, both underground and above ground, and it's becoming privatized in a lot of places. So when it becomes privatized, instead of a natural resource for everybody, then it becomes scarce. And of course, you know, a lot of the water is horribly polluted. So we lose that source of water. And there are more people on the face of the earth who want water. So yeah, it's becoming, there is becoming a shortage. I remember speaking to someone who was in one of the presidential, maybe 1 or 2 decades ago, Secretary of Agriculture. It was a cocktail party, and I happened to meet her, and she said, you know what the major cause of wars is? Oh, tell me. She said, shortage of water, people fighting over water. And as you can imagine, that's going to get worse and worse. And it's going to be a commodity that becomes precious because there isn't enough of it to go around.
Has anyone measured the percentage of water on the planet that's actually able to be drinkable? Or quantified that number? Or?
No, there probably is, but I don't know that number or that information. And
I was just wondering, I know in terms of the land mass, the only basically 10% of the Earth's land mass is just farmable. The rest of it is not farmable at all. So I just figured someone would come up with that number as well.
Is it really only 10%?
Yeah, it's 10%. And then out of that 10%, like most cities are built on fertile soil.
Yeah.
You have to probably deduct like a few percentage points for the amount of landmass that those cities occupy. So it's less than 10%.
Sure. That makes sense.
Yeah, which is kind of troubling. With
I mean, water. Yeah, it's we're only beginning to realize how scarce that commodity is becoming. And the solution is not so obvious, although if it becomes possible cheaply to desalinate water, you know, in the Middle East, that's essentially all the water they drink because they don't have a whole lot. in Saudi Arabia, for example, there are no rivers and no lakes. So they get tiny amount of their water from underground sources, and the rest of it is desalination. And they can do that because the heavy cost, it's run by energy, and the energy cost is really high, and they've got plenty of oil and gas. Mm-hmm. So they can run it at least for a period of time, but that's going to run out. When it runs out, they're going to be seriously in trouble. Mm. That's one of the reasons why some of those countries, especially United Arab Emirates, is trying to diversify. One of them is building a tourist industry, and you can see Dubai doing that. I was just visiting Dubai for a day or two, and the tall buildings and all the tourist attractions. So if this is a tourist attraction for you, the tallest building in the world, and the largest shopping center in the world, et cetera, et cetera. So they have the biggest, the largest, et cetera, a lot of stuff. And downtown Dubai is filled with buildings that they must have handpicked the, sorry, the phone is, they must have handpicked the architects to do that, because each building is more beautiful than the rest. But so because they know that they need to diversify, because the oil will dissipate, and after the oil dissipates, they're going to have a hard time. They're going to have a hard time dealing with water, producing water that's drinkable. So,
gotcha.
Yeah.
Well, do you have any closing statements before we end the call?
No, sorry.
Oh, you can stop really quick. I'll edit this part out. Or people are going to get your voicemail too.
Yeah, well, it's okay. This is Michiko Hayashi from the Emoto people, and she's leaving a message. I couldn't hear what she was saying, but okay. Something about coming over here. So I should get it. Well, anyway, we're about to close. Parting message?
Yeah, let me ask that one more time, and then I'll be able to crop it.
Okay.
And edit it. So before we close up, do you have like any closing statements or any other resources you would like to include?
Well, naturally, I would like people to read my latest book. It's designed for lay people, for non-experts. It's very popular on Amazon. If you take a look, it's called The Fourth Phase of Water.
Mm-hmm. I have it right here in front of me. Like, yeah, very beautiful, and it has, just for the listeners, a lot of illustrations. It's not like a very boring, just heavy text only type of book. So,
and I would also like people to come away with an understanding that's beyond just water, that science is a very complicated enterprise, and science has not produced very many revolutions in the past 30 years or 40 years, despite a huge amount of money that's put into it. And compared to, say, 100 years ago, when the physicists were producing scientific revolutions practically every year, when there was almost no money. So something is amiss, and I think it has to do with the way science is done these days. It's rather conservative, and even, I might say, among some scientists, even arrogant. We know what it's all about. Don't bother us with revolutionary ideas, because we got it all pretty much worked out. So, and if any are seriously interested in giving back to society, people who have done well, I encourage you to have a look at the Institute for Venture Science, because doing science and creating revolutions, which is what we're aimed at doing by supporting this, will create inevitably new technologies, and the new technologies that we might not even have dreamed of will solve problems that are currently a real challenge to solve. So that's a second parting message. And the third one is keep yourself hydrated.
Yeah, that's an important one.
Yeah.
Okay.
Yeah, thank you for your great questions, and it was really fun.
Thank you, Dr. Pollack. Thank you.
Okay, bye-bye.